In this video, we'll be solving the following problem. We'll find the derivative of this function, and then we'll evaluate the derivative when x equals 0. Now be careful here. We spend a lot of time in calculus taking the derivative, setting it equal to 0, and then solving for x. That's not what this problem is asking. Here we're going to replace all of our x's with 0 with substitution. We'll actually solve this problem in two different ways. So let's write it down again, our function. And we'll notice that we don't want to expand this out to the fourth power. That would be a really arduous kind of thing to do. We'll want to use the chain rule. So we'll be looking at our composite function, seeing the outside function and the inside function. But we can choose to do this either with the chain rule and the quotient rule, or the chain rule and the product rule. So we'll do this both ways. First, we'll do this just as written with the quotient rule. We'll start with the chain rule, and then we'll need to use the quotient rule. All right, so let's start with the chain rule. So we're taking the derivative, so we put our prime in. The chain rule, we can see that we've got this inside function here and the outside function to the fourth power. So we're just going to kind of ignore what's on the inside and say, I know how to take something to the fourth power. So that's a power rule kind of thing, x to the fourth power. We don't have just x, but we're going to say, well, let's do this in a power rule kind of way. So I'll bring my 4 down as a coefficient, copy down my inside function, and then I'll be subtracting 1 up here. So that takes care of the outside function. We use the power rule right there. And then we've got to come along and we've got to take the derivative of the inside function. So for now, I'm just going to mark that, that we need to take the derivative. We already said in this particular case, we're going to be using the quotient rule. Let me switch colors here. And let's think about what the quotient rule is. So if we have f equals u over b, one way to think about this, uv minus uv, and we'll take the derivatives of the bookends here over b squared. So if I want to take the derivative of this quotient right here, I could think about what's my u. My u is 2x plus 1, so u prime is 2. Taking the derivative of 2x is 2. Taking the derivative of 1, a constant, is 0. Then I set my v. v is 1 minus x. v prime, the derivative of 1, is 0. I keep the negative 1 in front here. The derivative of x is 1, so this is just negative 1. Then I can come on back here to my next line of work here. I'll have the derivative is 4. 2x plus 1 over 1 minus x to the third power. And then I'm going to fill in here with my quotient rule. So u prime v, u prime is 2, v is 1 minus x, minus uv prime, this is going to be 2x plus 1, v prime is negative 1, all over v squared, or the denominator squared. So in this case, I was just using this formula and subbing in each part that I found down here. So this is my derivative. This doesn't look so bad to simplify in the numerator, so let's go ahead and do that. So here I'll have 2 minus 2x. I'll have the negative here and here. That's going to become a positive. So plus 2x plus 1 minus x quantity squared. My 2x's go to 0, and I'm left with a 3 here. The 2 plus 1 gives me 3. So I'm just going to go ahead and take that 3 and multiply it by the 4 right here. So I'll have 12. And then I notice that I have a 1 minus x to a power 1 minus x squared here. So I'm actually going to rewrite this as 2x plus 1 quantity cubed over 1 minus x cubed. I can do that writing it separately like I did right there. And then I already took care of the 2 plus 1 is 3, and I multiplied that 3 times 4 right here. So this is just going to be 1 over 1 minus x quantity squared. So I'll have 12, 2x plus 1 cubed, and in the denominator, 1 minus x, and here I'll be adding my exponents, so I'll end up with the 5th power. I didn't have to do all that simplifying. In fact, in this problem, it probably would have been easier to just replace my x with 0 once I had the derivative and go, but it can be worth, a lot of people struggle with the algebra part of calculus where we're simplifying, so it can be worth practicing that a bit. Because if it had been the occasion where we wanted to set the whole thing equal to 0, then definitely I would want to go ahead with this form. Now, in this problem, we're just subbing in 0, so this is 12, and this will be 0 plus 1 cubed, 1 minus 0 to the 5th. This is just 12. Okay, so let's go the other way. Some people really dislike the quotient rule. So let's write this function down again. 2x plus 1 over 1 minus x to the 4th. And just like I did in the previous problem, I can write this in this way. And if I wanted to not have the quotient here, if I wanted to get rid of my fraction, I can rewrite this as 2x plus 1 to the 4th. And then bringing the denominator up will make this a negative exponent. So now I'm all set to use the power rule. Let's copy this down over here again. I'll have 2x plus 1 to the 4th times 1 minus x to the negative 4th. And I have a product. I have a product right here. So for sure I'm going to use the chain rule because I can see that inside and outside function, the composite function. But with the product rule, let's write down our product rule. The derivative, it's like our quotient rule here, uv. Now we're adding, and I'm going to take the derivative of the bookends right there. So in this case, I'm not going to write out all of my side work, but I am going to kind of note to myself, this is my u, and this is my v right here. And so I'm going to be following this formula as I go. So now that I'm taking the derivative, I have my f prime of x. So what do I want to do? I want to take the derivative of the first factor. So this will be a chain rule problem. I see the inside function in the parentheses and the outside function to the 4th power. So I will use this power rule, bring the 4 down to the front, 2x plus 1, and I'll have 4 minus 1. With the chain rule, I take the derivative of the outside, then I turn right around and take the derivative of the inside. So I'm going to take the derivative of 2x plus 1. Derivative of 2x plus 1, derivative of 2x is 2, and the derivative of 1 is 0. So I'll just leave that like this. So that was my u prime. Maybe even I'll label that right here. So all of this was my u prime. So then I need to come and copy down my v. That's my second factor right here. This will be 1 minus x to the negative 4th. Oops, I think I'm going to run out of room. Let's shift this down a little bit. All right, that was my v. Oops, it's okay. Highlighter, that's kind of cool. And we're going to add, and my u is 2x plus 1 to the 4th. That's my u. And then v prime, well, I'm going to have to use the chain rule again. So here I have my outer function, that's to the 4th, negative 4 power. So I'll bring that down and then I'll subtract 1. Negative 4, 1 minus x to the negative 4 minus 1. And then I'm going to take the derivative of the inside function. Derivative of 1 is 0. Derivative of negative x is negative 1. And here, let's continue with our highlighter. This is our u, and this is our v prime. Let's rewrite this a little bit, simplifying a bit here. So I can take my 4 and my 2, multiply, I'll get 8. 2x plus 1 cubed. This will be 1 over 1 minus x to the 4th power. And here, I can look at my constants. I'll have the -4 and the -1. That's going to give me a positive 4. 2x plus 1 to the 4th power. And this will be 1 over, so the -4 minus 1, -5. I'm going to put that down in the denominator. And in this problem, I'm not going to bother simplifying because I'm remembering that all I have to do beyond what I've already done, all I have to do is replace all of my x's with zeros in this case. And so I can just march right forward with that substitution since I don't need to do anything like set the whole derivative equal to 0. So we'll have 8. 2 times 0 is just 0, so this is going to be 1 cubed. 0 is a really nice number to plug in. 2 times 0 again is 0, plus 1 to the 4th power. And this is going to be 1 minus 0, so just 1 to the 5th power. So all these 1s make our life easier. This is just 8 plus 4, which is 12. The same thing that we got with our other strategy. So here again, we had to use the chain rule, and we opted to use the quotient rule in the first solution, and we opted to use the product rule in the second